A robotic arm resembles a human arm. It has a shoulder, an elbow, a wrist, and a hand. The shoulder is actually a stationary base to which the rest is attached. An engineer first designs all the parts on a computer. Then, those plans go into action. To form the base's outer casing, they bend steel sheeting into shape using a computer-guided press. Next, they paint the casing in powder paint using an electrostatic process that guarantees a thorough, even coat. They run a negative electrical charge to the casing and a positive charge to the paint particles. This makes the casing draw the paint to it like a magnet. Once the paint on the base casing dries, they use silkscreen printing to apply what's called the user diagram. It illustrates which parts move where and how. Now they build the robotic arm's hand called the end effector. Robots can be outfitted with all sorts of end effectors. Here they're making a gripper whose two claws come together to grasp and carry objects. To make each claw, an automated metal drill cuts a groove lengthwise and widthwise in a piece of aluminum. They assemble the electrical circuit board that will later go inside the base. The robotic arm's 6 separate motors will plug into it. Next, they assemble the mechanical parts of the base. First, the motor that makes the arm rotate. Then the gear that goes on the vertical shaft holding the robotic arm upright. When the motor makes the gear and the shaft turn, the robotic arm turns with it. At the arm's shoulder level, they install a system of 4 pulleys. Each consists of 2 plastic wheels on a separate axle with a rubber belt running between them like a clothesline. The belt has little teeth that grip grooves on the wheels. It rotates the wheels, making the robotic arm move. Each joint in the robotic arm is capable of and programmed for a specific range of movement. Like the human arm, the combination of these movements manipulates the end effector. They plug an electrical wire that links the gripper to the shoulder into a circuit board located in the shoulder. Then they screw the entire arm to the base. They link up the wires from the circuit board in the base to the motors in the shoulder. To do this, they have to bunch the wires, 48 of them in total, and thread them through the shaft that attaches the base to the arm. Once everything's connected, they fine-tune and test the gear and pulley systems to see if they run smoothly. Now they can install the gripper and the shaft and gear system that operates it. Turning the gear one way opens the grip, turning it the other way closes it. Now they mount the assembled gripper to the forearm, plugging its motor into a circuit board that they've already installed there. They plug the wires from all 6 motors into the main circuit board, which they then install at the back of the base. The robot controller, the brain that runs the arm, is a separate unit. It controls everything connected to the circuit. To move the robot, the computer inside the controller switches on all the necessary motors. It can control 8 motors, 6 in the robot and 2 optional accessories. You can program it to perform a variety of tasks. From start to finish, it's taken just under 30 hours to assemble this robotic arm. It can lift up to 4.5 kilograms, about the weight of a full-grown cat, and it can move at a speed of 2 kilometers per hour. Most robots are reprogrammable, meaning that to change their behavior, you simply write a new program. From an employer's perspective, robots may be the ideal workers. Granted, they have no ideas of their own, but their productivity is constant, they never call in sick, and they never take lunch or coffee breaks.